QLC NAND has lower endurance than TLC.
QLC NAND has lower endurance than TLC.
The PE cycle limit defines the usable lifetime.
The PE cycle limit defines the usable lifetime.
Endurance varies across blocks.
Endurance varies across blocks.
Bad block count increased after stress testing.
Bad block count increased after stress testing.
The error rate rises sharply near end of life.
The error rate rises sharply near end of life.
This workload accelerates wear.
This workload accelerates wear.
The device is approaching its endurance limit.
The device is approaching its endurance limit.
We're testing at 10 kPe cycles for qualification.
We're testing at 10 kPe cycles for qualification.
SLC mode extends endurance for critical data.
SLC mode extends endurance for critical data.
The endurance specification is workload dependent.
The endurance specification is workload dependent.
We need to track PE cycles per block.
We need to track PE cycles per block.
Write amplification reduces effective endurance.
Write amplification reduces effective endurance.
The endurance degradation follows a power law.
The endurance degradation follows a power law.
We're characterizing endurance across temperatures.
We're characterizing endurance across temperatures.
The device exceeded 3 kPe cycles without failure.
The device exceeded 3 kPe cycles without failure.
Endurance testing revealed weak blocks early.
Endurance testing revealed weak blocks early.
We need to define endurance requirements per application.
We need to define endurance requirements per application.
The PE cycle counter is tracked in metadata.
The PE cycle counter is tracked in metadata.
QLC endurance is sufficient for read-intensive workloads.
QLC endurance is sufficient for read-intensive workloads.
We're implementing adaptive PE cycle management.
We're implementing adaptive PE cycle management.
3D stacking increases density without shrinking the cell.
3D stacking increases density without shrinking the cell.
The margin shrinks as layer count increases.
The margin shrinks as layer count increases.
Program disturb becomes more severe at higher layers.
Program disturb becomes more severe at higher layers.
We're ramping 176-layer 3D NAND to production.
We're ramping 176-layer 3D NAND to production.
Vertical channel uniformity impacts performance.
Vertical channel uniformity impacts performance.
The word line stack height is reaching limits.
The word line stack height is reaching limits.
We're implementing charge trap flash technology.
We're implementing charge trap flash technology.
String current decreases with layer count.
String current decreases with layer count.
The gate interference effect worsens at higher layers.
The gate interference effect worsens at higher layers.
We need to optimize the vertical channel profile.
We need to optimize the vertical channel profile.
Dummy word lines isolate edge effects.
Dummy word lines isolate edge effects.
The cell-to-cell interference model changed for 3D.
The cell-to-cell interference model changed for 3D.
We're testing beyond 200 layers in R&D.
We're testing beyond 200 layers in R&D.
The aspect ratio challenge requires new etch processes.
The aspect ratio challenge requires new etch processes.
Peripheral circuit placement impacts die size.
Peripheral circuit placement impacts die size.
We're implementing CMOS under array architecture.
We're implementing CMOS under array architecture.
The 3D cell size is nearly constant across nodes.
The 3D cell size is nearly constant across nodes.
Word line resistance increases with layer count.
Word line resistance increases with layer count.
We need new program algorithms for tall stacks.
We need new program algorithms for tall stacks.
The process complexity grows with layer count.
The process complexity grows with layer count.
The program voltage must be carefully controlled.
The program voltage must be carefully controlled.
Erase operation resets all cells in a block.
Erase operation resets all cells in a block.
We're seeing program disturb on adjacent cells.
We're seeing program disturb on adjacent cells.
The program time increased after cycling.
The program time increased after cycling.
Incremental step pulse programming improves accuracy.
Incremental step pulse programming improves accuracy.
Erase verification ensures complete cell reset.
Erase verification ensures complete cell reset.
The program efficiency degrades with wear.
The program efficiency degrades with wear.
We need to optimize the program pulse parameters.
We need to optimize the program pulse parameters.
Pass voltage affects program disturb margin.
Pass voltage affects program disturb margin.
The erase operation takes longer at low temperature.
The erase operation takes longer at low temperature.
We're implementing smart program algorithms.
We're implementing smart program algorithms.
Overprogramming can cause reliability issues.
Overprogramming can cause reliability issues.
The program sequence is optimized per block age.
The program sequence is optimized per block age.
Erase stress accelerates endurance degradation.
Erase stress accelerates endurance degradation.
We need tighter program voltage distribution.
We need tighter program voltage distribution.
Retention degrades after repeated PE cycles.
Retention degrades after repeated PE cycles.
Data retention is temperature dependent.
Data retention is temperature dependent.
Read disturb affects long-term reliability.
Read disturb affects long-term reliability.
The retention specification is 1 year at 40C.
The retention specification is 1 year at 40C.
Charge loss accelerates at elevated temperatures.
Charge loss accelerates at elevated temperatures.
We're testing retention after 10 kPe cycles.
We're testing retention after 10 kPe cycles.
The retention margin depends on program state.
The retention margin depends on program state.
Cross-temperature effects impact retention.
Cross-temperature effects impact retention.
We need to refresh data for long-term storage.
We need to refresh data for long-term storage.
Retention failures increase near end of life.
Retention failures increase near end of life.
The threshold voltage shifts over time.
The threshold voltage shifts over time.
We're implementing predictive retention monitoring.
We're implementing predictive retention monitoring.
High-temperature bake tests retention limits.
High-temperature bake tests retention limits.
The retention distribution widens with wear.
The retention distribution widens with wear.
We need error correction for retention failures.
We need error correction for retention failures.
The controller compensates for device aging.
The controller compensates for device aging.
ECC corrects bit errors at the hardware level.
ECC corrects bit errors at the hardware level.
The error rate increased after 5K cycles.
The error rate increased after 5K cycles.
We're implementing LDPC error correction.
We're implementing LDPC error correction.
Raw bit error rate determines ECC requirements.
Raw bit error rate determines ECC requirements.
The ECC overhead reduces usable capacity.
The ECC overhead reduces usable capacity.
We need stronger error correction for QLC.
We need stronger error correction for QLC.
Uncorrectable errors trigger data recovery.
Uncorrectable errors trigger data recovery.
The error correction latency impacts performance.
The error correction latency impacts performance.
We're tracking error statistics per block.
We're tracking error statistics per block.
Soft errors require read retry mechanisms.
Soft errors require read retry mechanisms.
The ECC engine operates at line rate.
The ECC engine operates at line rate.
We need to balance correction strength and overhead.
We need to balance correction strength and overhead.
Error injection testing validates ECC robustness.
Error injection testing validates ECC robustness.
The decoder complexity increases for stronger codes.
The decoder complexity increases for stronger codes.
Wear leveling is essential for lifetime management.
Wear leveling is essential for lifetime management.
The firmware update improved stability.
The firmware update improved stability.
Write amplification should be below 2.0.
Write amplification should be below 2.0.
We're implementing dynamic wear leveling.
We're implementing dynamic wear leveling.
Hot and cold data need different management.
Hot and cold data need different management.
The garbage collection efficiency impacts performance.
The garbage collection efficiency impacts performance.
Over-provisioning extends device lifetime.
Over-provisioning extends device lifetime.
We need to track writes per logical block.
We need to track writes per logical block.
The flash translation layer manages address mapping.
The flash translation layer manages address mapping.
Static wear leveling moves cold data periodically.
Static wear leveling moves cold data periodically.
The wear leveling algorithm impacts endurance.
The wear leveling algorithm impacts endurance.
We're optimizing the block allocation policy.
We're optimizing the block allocation policy.
Write coalescing reduces program operations.
Write coalescing reduces program operations.
The FTL metadata overhead is 2% of capacity.
The FTL metadata overhead is 2% of capacity.
Background operations should minimize latency impact.
Background operations should minimize latency impact.